For the next 10 minutes, we are going to talk about the current challenges and technologies behind mobile robots operating in outdoor conditions. In on-road conditions, like self-driving cars, and in off-road conditions, like planetary exploration rovers. In this presentation, first we are going to have some definitions related to mobile robotics and some categories of mobile robots. Then we are going to talk about the main challenges of mobile robots in outdoor conditions. And the second big part of this presentation is going to be related to trending technologies supporting mobile robots. And finally, we will discuss a little bit about open questions and the future of mobile outdoor robots. Mobile robotics started back in the 1960s, mainly in using manipulator robots for the automotive industry. But soon researchers and engineers realized the importance of building and assembling, programming robots with the ability to move. It was in the 1970s where the area of mobile robotics was born. After that, we have very successful projects, mainly coming from academia, like the Terregator robot from Carnegie Mellon University and the Stanley self-driving car developed by Stanford University. And then, more recently, in 2010, the NASA rovers that were sent to Mars to explore Mars, like the successful MER mission with the Spirit and Opportunity rovers, and more recently the Curiosity rover. There are two big areas related to mobile robotics: outdoor robots and indoor robots. These two areas are quite different. Indoor robots are mainly used in warehouses, factories, museums, homes, and on the other hand, outdoor robots, we have two different categories. The first one, intelligent vehicles, dealing mainly with self-driving cars, and on the other hand, we have field robotics. So these robots are used in very different areas, from underground robots, ground robots, underwater vehicles, etc. So what are the challenges, the current challenges of mobile robots operating in outdoor conditions? So the area of mobile robot use in outdoor conditions and indoor conditions are quite different, mainly because mobile robots operating in all outdoor conditions are facing challenges, real challenges, like the interaction between the robots and the terrain, the weather conditions. We can have snow, we can have bad light conditions, but it's very important, in particular, the area of the interaction between the robot and the terrain and the environment. If the engineers behind this project that do not take into account this, we can even lose the mission of the robot. Regarding the area of intelligent vehicles, on-road mobility, the challenge is how you move on that surface. Okay, so in particular, how we can implement in the area of self-driving cars, how we can implement all the driving laws, but even most importantly, how the robot behaves when another vehicle or another, human being can break the law. Okay. Another trending area related to self-driving cars is to try to understand the behavior of the human beings. For example, in this picture, is this mom and his kid waiting to cross the street, or are they just looking at the bus? So depending on that behavior, the robot will have to stop or we have to keep moving So it's very important to understand this and to apply artificial intelligence to understand this behavior of the human being. Regarding the area of field robots in off-road mobility, here the challenge is the interaction between the robot, the wheels, or the tracks, or the locomotion mechanism of the robot with the terrain. For that reason, it's very important the area of terramechanics and artificial intelligence to combine both of them. Because terramechanics is related to the study of the forces and the kinematics elements between the wheels and the terrain. So if we combine terramechanics and artificial intelligence, we will be able to control much better the motion of the robot in order to prevent or to avoid these situations related to the interaction between the wheels and the terrain. One very important problem in the area of field robots, in particular ground robots, is related to non-geometrical hazards like the slippage events, embedding, and entrapment. This is so important that even the robots that are sent to Mars, for example, the Opportunity robot mission was lost because the Opportunity robot got stuck in a sand dune. Okay, so it's very important to detect when the robot is sleeping. The second big part of this presentation is related to trending technologies applied to mobile outdoor robotics. Okay? We can talk mainly about three big areas: computer simulations, in particular autonomous vehicle simulation software tools, autonomous navigation, okay? How we control the motion of the robot. So we can go from point A to point B autonomously. Okay? The robot can make his own decisions. And finally, another important area is related to electromechanical components, hardware, energy systems, sensors, and the locomotion of the robot. Right now, a trending area related to computer simulation is how we can design software tools that can integrate advanced high fidelity models of a robot with a integrated development environment where we can program different control strategies and see in real time, in a simulation in real time, the motion and the behavior of that robot. Okay? The second big area related to trending technologies is autonomous navigation. And perhaps this is the most important area because it's going to be responsible for the success of the robotic mission. Okay? So here, artificial intelligence is the best player. Okay? In particular, symbolic AI, expert systems, and control theory, and machine learning. How the robot can learn from his experience. Okay? Here we have trending areas right now: neural networks and deep learning. Okay? How the robot can learn from his experience, how we can classify and identify trending areas in the terrain with like slippage, or how we can identify autonomously traffic signs, etc. And another very important area dealing with trending technologies is the electromechanical components, hardware, like these very popular technologies related to Raspberry Pi, Arduino, tough computers for all weather conditions, sensors like LiDAR, IMUs with GPS, RTK GPS, stereo vision. Locomotion is also subject to a big effort by the academia and by the research community, and even for the companies, like different locomotion system, the design of the wheels with grouses, etc. So finally, open questions and the future of mobile outdoor robotics. So these are, in my view, the open questions that we have right now. enabling outdoor robots to drive farther per day, especially in terrains with mobility hazards. Reducing energy consumption and maximizing traction. This is to take a special consideration of the control software of the robot. Also allowing the robot to move autonomously in dark or shadowed areas and in all weather conditions. What happened to the robot when we move under snow, rain conditions, etc. And estimating in real time variable variables like sinkage, soil cohesion, etc. And finally, the future of mobile outdoor robotics. In my view, there are three big areas: space exploration, defense, transportation with self-driving cars, and agriculture. Okay? These four big areas are going to be part of the future of all the community supporting mobile robotics. Okay? Here are some references so you can check after this presentation in order to dig more into all these particular aspects. Thank you very much for your attention. It was my pleasure. Thank you. Bye.